and post the recording on the class website. So when you study for the test, you can come back and watch these videos. So we finished chapter 2 and chapter 3. I put the link here under week 2. Oh, we have, yeah, this is the first thing I want to remind you. We have a quiz 1, uh, which will be tomorrow. It will start tomorrow at 5 p.m. So make sure you take the quiz between tomorrow, February 12, and February 13, 11:59 p.m. Okay, make sure you take this quiz within these 2 days. Otherwise, you will miss the quiz. And the other thing, you notice that this quiz requires lockdown browser. Make sure that you download the lockdown browser and make sure it works on your laptop or computer. If you wait until the quiz starts, you will not probably be able to do that. If you don't have a computer, you can come here to the lab. We have computer lab here in our building, and the lockdown browser is already installed. You can use any computer and take the quiz or the test. Okay, so this quiz covers chapter 1 and chapter 2. And here's the link for the lockdown browser here. It's under week 2, and I put it also, I think I put the link. Oh, this is a recording. I put the link also here, I think. Oh no, it's on the announcement. Okay, this is quiz 1, which is due after tomorrow. Not tomorrow. You can start taking it tomorrow at 5 p.m. You have from tomorrow 5 p.m. to after tomorrow midnight. Okay, this is one thing. The other thing, there is here a discussion form. You need to. Oh, I have some 89 replies. That's good. So some students asked me about that. I will grade that. I will read all. So this is a discussion between the students. You need to discuss, as I explained, the types of customers. We have satisfied, dissatisfied customers, delighted customers. Okay, and you need to give an example. So sometimes you uh, buy something and you have some expectations. So we need to know if this product or service meets your expectations, so you are satisfied. If it doesn't, so you are not satisfied. If it exceeded your expectations, so that means you are a delighted customer. So make sure, the deadline also here was February 10th. So there is an assignment which is due on February 21st, this one. So in chapter 3, I put there is a video for Pareto chart, explained how to build a Pareto chart. Even on the assignment, I just asked general questions about Pareto chart. I did not ask you directly to build a Pareto chart because, sometimes I ask questions to build a histogram or Pareto chart, but this time I did not. I removed that question. But you should know how to build a Pareto chart, and there is a video recording here. It's very easy, just one step. I explained this on the video. With Excel, you just select and insert Pareto. It will give you the Pareto chart, but it's also more important to know what's Pareto chart, why we use it, when we use it, how we build it. Okay. And there is a quiz here. Again, this quiz covers chapter 3. Okay, it's due on the February 24th. Here you have given 2 or 3 days to do that. Notice that it's AM, so it's February 12th at night. The 22nd at night will start, and the deadline is February 24th at midnight. So, okay. Any questions? Okay, let's talk about chapter 4. So this is the last chapter before the midterm. So I put some instructions here. You will need this. How to install. I think this is a video how to install the analysis tool pack. I will. Okay. So for chapter 4, let me look at chapter 4 here. So there are like very important topics in chapter 4 where you need to understand. You know, chapter 4 is process measurement. The first few slides just like definitions and concepts, value stream map. It's a map of all activities involved designing product. We use it in lean manufacturing in Six Sigma. Okay, it's a map which is used to describe processes and sequence of processes, and then we can calculate the process times and add it to the value stream map, value added time and value added time. So we just need to know here what's the value stream map. Critical to quality data collection, you know, data sheets and check sheets. We talked about that. This is one of the tools of quality. Sampling, I think we will cover sampling in detail. I remember we have a chapter about sampling, but sampling, you know, when they do the quality check or when they inspect the products before they deliver to the customer, there are different types of inspections. So maybe for some products, they inspect every single item leaving the facility. But if, for example, let's say we have a huge production, like, and we cannot inspect every single item, so they use what we call sampling. So we take a sample and inspect it. Okay, inspect this sample. So if our lot size is 1,000, for example, parts, and we don't have time, and maybe it costs too much money to inspect all the items. So in this case, what we do, we select like 10 out of the 1,000 and inspect them. If the 10 are good, there should be a plan, which is called sampling plan. This is another topic, you know. And then we let the lot pass. If based on the sampling plan we select, if, for example, we have 7 out of the 10 bad products, we reject the whole lot, for example. Depends. These are the types of sampling: random sampling, systematic sampling, judgment sampling. So you need to read these types. They are easy. Random, when we say random, it's random. Even using random numbers, um, there are like tables for random numbers, for example, or sometimes we use Excel. For example, if I want to select 10 numbers out of 100, the easiest way, I just use Excel. So I just say, okay, between 1 and 100, select 10 for me. So if my lot consists of 100 and you were asked to select 10 out of the 100 randomly. So let's say these are the 100 parts I have. Let's assume every circle represents a part. 1, 2, 3, 4. I give them numbers until 100. Okay. So now I need to select 10 of these. So the first one I go for 89. Oh, this is 89. I select it. The second one 96. So this is 96. For example. I select 94. This is 94. I select 56. This is 56. For example, I select 55. This okay. I select these 10 out of the 100. This is random sampling. Sample size. So you need to know, for example, when I said, oh, we have a lot of 1000 and we selected a sample of 10. Is the number 10 represents the sample? So that's why we need to calculate the sample size. So using these equations, we can calculate the sample size. To have sampling error for population mean of, so from this we know that this is the error should be given or less, and 101 minus alpha confidence level. So the sample size n is equal greater or than z alpha over 2, okay? This is squared sigma square over error square. Okay, sigma, you should know sigma. You will be given the standard deviation, you square it. The error, you will be given the required error. Okay, you will square it also and divide the squared, which is the variance, is the, so we know the sigma square is equal to the variance. So sigma is the standard deviation. So if you are given the variance, that's the standard deviation square. So what you need to do, you need to find the z value associated with this alpha. So when we say 99% confidence level, so the confidence level of 101 minus alpha, that means for this case, alpha is equal to 1 minus 0.99, which is 1%. And the 1% is 0.01, right? So this is alpha over 2. So I need z of 0.01 divided by 2. So I need to find the z for 0.005. We will learn how to do that. For example, if you are asked to find the sample size with a confidence level, what's the confidence level? I think also we will cover this in details later. Like when you say 99%, so at the end you say 99% confidence level. I am 99% confident that this sample size is a good representative of the whole population or lot. If you are using 90% confidence, so your confidence is less. So I am 90% confident that this sample is a good representative for the population or the lot. Okay. If you have proportion, you use this equation. Here, if you have the standard deviation or the variance, you use this equation. Let's see this example. I think this is example. Yeah. Here, a similar task to determine the sample size split population proportion for discrete data. The sample size required to have a sample error plus. Yeah, we talked about that. So where pi is the population, generally pi is not known. So we can use estimate based on a sample or past experience. If no estimate is available, if it is given, if I tell you pi is equal 0.7, don't use 0.5. But if there's no estimate, you use 0.5. Any questions before I go over the example here? There will be questions on the quiz on the midterm exam similar to these questions. So make sure you understand the concept. And if you have questions, ask. And again, after we finish, I will post the recording for this meeting. And it's good if you go over it and understand everything we covered. And if you have additional questions, you can come back to me. So managers believe that the average time to process package at the front counter of a post office is about 3 minutes. So the average is given 3 minutes. They want to do work sampling study to estimate the time more accurately. From the small pilot sample, the standard deviation, see, they are giving you the standard deviation. Here I am given the standard deviation. What happened here? Let me look at the chat. Somebody asked question. Yeah, sure. Okay. 60 minutes. Management wants to find the sample size needed to achieve maximum allowable sample error. You see, we are given the standard deviation. We are given the error. Okay, so I am given the error. And now the point with 95% confidence interval, calculate the sample size. So now we said, let me take, I will copy this and I will open a new slide here. So I want to show you how to put this here. Yeah. So we said we know sigma, it's given. So if they say that they said the standard deviation, sigma square, sigma is 0.16. Sometimes they give you the variance. Sigma square is equal to a value. So the variance is equal to sigma square. If they give you the variance, you just put it as it is, okay? Divided by the error. So we need to find Z alpha over 2. So they said 95%. So 1 minus 0.95 is equal to 0.05. So alpha is equal to 0.05. Alpha over 2 is equal to 0.05 over 2, which is 0.025. Okay, so now what should I do? How do I find Z? I go to the table. You know where's the table? Here's the table. I put the table for you here. If you click on this, you see, download this, keep it. I have a copy somewhere here. Here. So we are looking. So we know that the area, this is the standard normal table. We call it standard normal table. Of course, you should be familiar with this table because you should have taken statistics and operations management. If you don't know how to use this table, so that means you do not meet the prerequisites for this class. Okay, you will be struggling. So, but I will show you how we are using the table. So usually when we do the normal and when we do the sigma, you know, we know Z and we find the area. But here in this case, we know the area and we need to find Z. So the area we know, we said 95% confidence interval or level. So alpha is equal to 0.05, which is 1 minus 0.95. Alpha over 2 is equal to 0.025. So I need to look here and find where's the 0.025. I have 0.026, 0.0228, point oh here. Okay. So 0.025. So Z is 1 point. I take the first two digits from the first column for Z, and the third digit, I take it from here. So my Z is 1.96. It will be squared, so it doesn't matter if you put negative for this case. So here, you see the Z is 1.96 squared, and then I multiply by this, and then I find. If it is rounded on the question, you know, you round. If you see like fractions, just use it exactly as it is. Usually I don't round actually for me. But it should be rounded because it is n, it is people or usually on my questions I don't round, so I will not cause a confusion for you. Okay? Any questions? Okay. This is the same thing here. We are given pi. So here I copied this from the textbook, but probably they found the wrong Z. So they said 99%. So for 99%, or they used Excel or something to find the Z. For 99%, so alpha is equal to 0.01. So alpha over 2 is 0.01 over 2, which is 0.005. See, if I go to the table and find, you are given pi here. So 1 minus 5 times 1 minus pi divided by the error, and then you multiply this by z alpha over 2, which is the 0.005. I need it here somewhere. See, this is 5.7, 5.2, 5.1. It should be between these t values. So usually what I do, 2.5. Oh, these two values here, 7.5. Okay. But I know if you selected this and this, you will find the correct answer. Because when I ask a question like this, I will not put an answer for this and this, so you will be confused. But if you select this or this, that's fine. The answers will be far from each other. So, okay. So please review what we did on the normal table. It is very important to know how to use this table. It is very extremely important if you don't know, because later we will be using this table. And if you forgot, because we learned that in business class, the business statistics class, we learned that also in operations management class. You should be able to know how to use. These are types of data. They are different and categories. Oh, that's very important. I just put these slides, and I put actually the quiz for chapter 3 to make sure that you understand or you still remember the basics of statistics. I put those basics here for you. So, descriptive statistics, we know the descriptive statistics measures the location. So, mean, median, mode. So, the mean is the sample average or mean. Median is the median value. Mode is that most frequent value within the data. For example, find the mean, the average for this data set. I just add them up. See, I added them up and divided by how many. The median or the mean also for this, see, 3 plus 9 plus 4 plus 2 plus 70 divided by 5, okay? So the median is the middle value. So if we have 1, 2, 3, 4, 5. So the first step to find the median and to sort them from smaller to larger, they are already sorted. And then I look for the middle value. I scratch one from here and one from here. So this is the median. Okay, it's a position. The median gives you the position of like the value in the middle as a position, but the average or the mean gives you the value as a value because you add them up. Okay, if you have if it is even number, so we said this, so the median would be 5 plus 3 divided by 2, which is equal 4. I mean, this is the formula for the standard deviation, sum of x minus x squared under the square root divided by n minus 1. This is the variance. This is the standard deviation. The range is the difference between the minimum and the maximum. Mode is the most frequent one. For example, the mode for this data is find the mean median mode for this data. If I am asked a question like this, so I will take this data, for example, this is the normal table. So there are like different ways to do that, but let's say this data, I want to find the mean or the copied data I just copied. You know, as I said, I can use the data analysis toolpack to do that. Okay. And I put the range. Let's say this. Sometimes I remember Excel used to ask us to put it in one column, but let me try and see. Yeah, they are in columns here. It's better because sometimes, so I'll put it in one column. And then let me show you if you have not watched how to install the data analysis toolpack. I click on File, Options, and then I have add-ins. Okay, Analysis Toolpack. Okay, I click on not OK, I click on Go. If you click on OK, it will not be installed. Go. Make sure this is marked and then click OK. So when you click on data here, you will have the data descriptors. This is the analysis toolpack. Okay. So I click OK. I select the data here that I need to analyze. And then since it is in column, so I have column. And then output range, I select the output range, select whatever you want. Summary of statistics, confidence level. Now it will give me everything I need. This is the mean, this is the median, this is the mode, this is the standard deviation, this is the range, this is the minimum, this is the maximum, this is how many, this is the sum, this is the confidence level. Okay, so here I put this also here for you. You can do it one by one, like here, the average, the standard deviation, for example. But in this way, I did everything once in one click, you know. But of course, you can bring this up while it is down there. You can find equal the average, for example, and select all these. It will give you the average, which is the mean. It's the same here. But as I said, this way is better. It will give you everything at once. Okay. Using Excel median mode, Yeah, it's the same. Proportion is a fraction. Any questions? Okay. Proportion is a fraction of data. When you say proportion, like 2 out of 5 is 2 over 5. 5 over 10 is 5 over 10. Okay. CS is a measure of degree of symmetry of observation. CK is measures of peakness, high, narrow, or flatness of a histogram. So this is a histogram. A histogram is one of the methods that we use to visually represent data. It's a very important tool. So the histogram here, it shows the frequency here. If you are using frequency histogram, you can use relative frequency histogram. So if it is a frequency, so this column, if we have 10 here, so the frequency of this value, for example, this is 1 to 10 is, so the value or this bin, we call it bin, between 1 and 2, let me give numbers here, 3, 4, 5, 6, 7, 8. It's put here 12, 15, 20, and here 12, 15 should be 12, 10. So if I ask you, based on this frequency histogram, how many items are there? What's the population or sample here? So between 1 and 2, 10, plus 15, 12, 27, plus 15, how much? 42, and 20, 42 and 20, 62. And since this is symmetrical, I have 62 here. 62 plus 62 is 124. Okay, so the total frequency is 124 because I have 10 between 1 and 2 and 12 between 2 and 3. So what is the relative frequency for the first interval, which is 1 to 2, which is 10 divided by the total 124. Okay, what is the relative frequency for 4 to 5? I look at 4 to 5, the frequency is 20, for example. So 20 divided by, something wrong with the internet today, by 124. But anyway, this will be recorded. Okay, this is the histogram. So I put, oh, this is how we add what we did. If I want to, it's very easy to build a histogram. I take this data. I think I took it. I put it somewhere here. You copy it, you see the same data. I put this data here. So to build the histogram, I select this data. I think I'm sharing my screen, yeah, right? Yeah. If I forgot, I have to redo the whole video. It happened. Okay, then insert. And then select histogram. Look how fast is that. So now I have my histogram. Okay, let me remove this. And let me, of course, you need to give the histogram title. You need to add access titles. So for example, this is grade, let's say, and here frequency. And also I can do other things. Oh, can add the legend somewhere. Okay. I have a recording. I put this stuff on a recording. Access titles, legend. I don't like. You can do that. So for example, here between this, the 185 and 235, we have four frequencies. Four. It's 8 here. It's 30. It's 4. It's 3. It's 4. It's 3. 1. Okay. So what is the relative frequency for this? Can do whatever you want. I can do this, for example, format. I can change. This is the same Instagram, what I did. I need to remove this. See, I click on this and right click and format axis. It will show this now. Bin width, you see it is 1.5 to 2.85. I need to change it. I can change it to, for example, to 1. Okay. So of course, when it is changed to 1, oh, 1 doesn't look. Let's change it to 0.5. See, it's better. Yeah, do this. I like this. The actual histogram, there should be like something separating the intervals from each others. Okay. Yeah. All these are like some definitions here. Oh, the last thing which is very important is process capability. So process capability is used to measure the capability of a process. So if we have a process and we want to know if it is capable means that the process is producing good parts. Okay. What's the opposite of good? Bad. In the industry, we call it like defective. So it means like we are making parts. We don't want to make defective parts. That's the point here. So we have to measure what we call process capability. This is a very important topic. You need to spend some time on it. Again, as I mentioned, this is online class, so it is very important that you read the chapter 2-3 times to be able to understand these concepts. I'm doing these meetings just to help you guys to understand, okay? So CP, we have CP and CPK. So CP is calculated by using this equation where CP is equal upper specification limit minus lower specification limit divided by 6 times sigma or sigma hat. I like to use hat. USL is the upper specification. Sometimes you will see in this textbook they use UTL only, which is upper tolerance. It's the same. So this will be given. So for example, if we are so let me copy these again. I have another class in 15 minutes. So if we say all the average is the tolerance or the specifications are 50 plus minus 2. So the upper specification limit is 50 plus 2. The lower specification or T here is 50 minus 2. Okay, so this is easy and this will be given. So what you need to do, you just plug in the numbers and find the answers. So I have an example here from your textbook. So I think I put it here. Yeah, I will use the Word document. Suppose that the process at manual automation with normal distributed output has a mean of 50 and variance. Look, they gave you the variance. Don't be confused. If you need to find the standard deviation, so the standard deviation is equal to the square root of variance. So for this case, if I want to calculate the CP, they give you the variance and they give you the specification. So this is a very straightforward question. So CP is equal to the upper specification limit minus lower specification limit divided by 6 sigma. And they give you the specification 51. This is the upper specification limit 51, which is given here, plus 3.75. Lower specification limit 51 minus 3.75. See? So 54.75 divided by 6, number 6, times the standard deviation. So you are given, most of you, if I ask this question, they will divide by the variance. No, you need to find the standard deviation, which is the square root of V, which is equal to the square root of 361. Okay, and then find the value for CP. For CPK, there is another measure which is used, which is called CPK, because the CP as unit it does not involve the average of the process. The average of the process is, if we are dealing with the population, it is mu. If we are dealing with sample, it is X bar or X double bar. So it depends. Here they are dealing with population. They use, so here, if the process is centered, we use this. This is a good measure. If the process is not centered, we use the CPK. CPK, you need to find, we use the same values or information we calculated here. So upper specification limit minus the average divided by 3 sigma. And then we find the CP. This is the CP upper or CPK upper. They call it sometimes CPK upper, CPK lower. CPK lower, mu minus lower specification limit divided by 6 sigma. For our question here, the CP upper is the upper specification or tolerance minus X bar. This is given, this is given, this is given, this is given. So we know this, minus 50 divided by 3 sigma, it is 0.833. The lower CPK, it's the X bar, or sometimes we use X double bar. if you are working on control charts, we will cover control charts later. For population, we use mu. Okay, so the average minus the lower specification limit divided by 3 times 1.9. So you have two values. You have the upper and lower. So you'll select the lower value. Okay. So the CPK for this process is 0.483. Okay, the smaller value, the smaller one. Okay. So I have another class right now. Any questions? If you have questions, just contact me. Again, for those who just joined, we have too many things to do. We have a quiz due after tomorrow. Make sure you take the assignments on time. Make sure you take the quizzes on time. Make sure you check the website every day. Every day I put lots of information, recordings. I will post this recording probably tonight or tomorrow. It will be under here. And I have another recording, but I will post that recording after the quiz because there are like some solutions for the quiz. Okay, we have quiz here. We have quiz here. We have assignment here. Okay. And if you have any, we have the midterm exam. I have not talked about the midterm exam. I put the midterm exam here. Oh, my internet is not good, but between 25 and 28. But maybe if you want, I can push it like for March 1st. You can push it one more day because the actual midterm exams they start on the 3rd. So February 25th would be Tuesday. So it will be available from Tuesday to Friday. I can push it to March 1st. I don't care. Okay, I will push it more. I will push it more. 1 or 2 days. Okay, any questions? I need to go to my other class. If you have question, feel free to contact me. Make sure you study all the material, watch the videos, do the homework, and if you need any help or you have questions, send me email. Okay, thank you.